Hello, my name is Tu, and this is my project for the Machine Learning Foundation for Product Manager course. The agenda is that first I'll go over the objective, then the exploratory data analysis. Third, I'll go over the feature correlation matrix. Fourth, the relevant feature visualizations. Fifth, the model I use to test. And sixth, I'll end it with a conclusion. Our objective today is to build a supervised machine learning model to predict the electrical energy output of a combined cycle power plant. To generate power, it uses a combination of gas turbines, steam turbines, and heat recovery steam generators. The dataset is generated from hourly ambient sensor reading. So the exploratory data analysis I use is first I wanted to see what kind of shape the data provided, and also I wanted to know how many rows and column this electrical data set has. Second, I wanted to know if there's any empty values in the data set. And then third, I wanted to see the min, the standard deviation, the mean, 25, 50, 75, and max percentage of each of the column in this data set. So as you can see, the AT is actually the temperature. V is actually the vacuum exhaust. RH is the relative humidity. AP is the ambient pressure. And lastly, PE is the net hourly electrical energy output. So I wanted to see what the correlation matrix is because there's only 5 column in this data set and relatively a very clean data set, which is unheard of. And I work with data quite often. So using this correlation matrix, you can see that the temperature and the exhaust vacuum has a negative correlation that is very high. So using the correlation matrix, I graphed the temperature feature and the exhaust vacuum feature. And I can see that it's very linear with the training data set and the testing data set. The machine model I use to test is a linear regression model using just the temperature feature, and it produced an 89.9% model score. Another model that I use is a multilinear regression using temp and exhaust vacuum, and that produced a 92.8% score. I also used the linear regression for the exhaust vacuum, and that gave me the lowest score, which was 74.9. And as a bonus, I used another model, and that was the gradient boosting using temp and exhaust vacuum. And that was actually the highest score that I got, and that was 94.4. As you can see on the screen, there is four different model that I've used, and the one that yield the highest score is the gradient boosting. So for this project, I will say that is my machine model that I'll go with for this data set. And that's it for my presentation. Thank you so much. Have a great day.